All right, we are going to begin the infinite limits. We're going to talk about what happens when you have a limit where x is approaching infinity. And infinity is a little bit of a different beast because it doesn't necessarily behave like numbers do, but in some cases and in some ways it does. So we have to kind of think about, okay, what happens when x gets really, really, really big is kind of the idea. Or n, or whatever the letter happens to be. What do we do? So I'm saying x, but this could be any variable. So just to clarify that, it doesn't have to be x. But what happens when the variable goes to infinity? As you approach infinity, what do I do? So we know the concept of direct substitution. So the first thing we're going to do is try to plug it in. And so if I plug it in here, I get 1 over infinity squared. Now infinity looks a little funny or acts a little differently because infinity squared is really just infinity again. And then 1 divided by infinity, if you think of infinity as just the biggest sort of possible number you can think of, and then it helps understand, well, if you square the biggest number, you're just going to have a big number again. It's just infinite. These things are, mathematical operations don't really work the same with infinity. But we know that if you take 1 and divide it by a really, really big number, just conceptually, that's going to approach 0. All right? So we're kind of thinking of infinity as just a really big number for our purposes. Now that's, subject to some debate about what infinity actually is or how it operates, but for our purposes, we're going to think of infinity as a really big number, the sort of biggest number you can think of. So if we think about infinity that way in terms of limits, and again, I'm not saying that that's always the way people view infinity or even the best way to view infinity all the time, but for our purposes, we're going to do that. And if you have a number, just there's a certain operations you need to know about infinity. So if you have a number divided by infinity, that number not being infinity, then your answer is always 0. Okay, and that's important. If you have a number that is multiplied by infinity, okay, then, and that number is not 0 and it's not infinity, then your answer is infinite. Okay, again, you should make a little note that that's not 0 or infinity. Okay, particularly if it's not 0, because that gets into indeterminate forms we're going to talk about later in L'Hopital's rule. And if you take infinity and raise it to a power, so if you take infinity raised to a number, you just get infinity. Okay, you don't have to worry about some of those operations. So just some things about infinity that are a little different. And we're going to talk also about negative infinity versus positive infinity. If you're approaching negative infinity, then this is still true. It doesn't matter whether this is plus or minus infinity. The result is still 0. But if it's a number multiplied by negative infinity, then depending what that number is and depending what this sign is, the rules of math still apply in terms of plus and minuses. So that could be positive or negative infinity. And then if you have negative infinity raised to a number, depending on what that number's value is, it could be negative here if it's an odd power. So we'll talk mostly about approaching infinity, but sometimes you're going to approach negative infinity. If that's the case, you just have to be careful of your signs. So what do we do if something doesn't work right away? Okay, if something works right away, perfect. But if we get infinity over infinity, then something has to be done, because if you have infinity squared and you have infinity minus 1, then that's going to give me infinity divided by infinity. Okay. Now our tendency is to think, well, that's just 1, but that is not true all the time. Sometimes it is, but sometimes it isn't, because conceptually, if you kind of think about it, and it's just strange. It hurts the head sometimes to think about it, but infinity squared, well, that's going to be a bigger infinity than infinity minus 1. But then how can you be bigger than infinity? And so you understand where the sort of problems arise with infinity. But infinity over infinity is an indeterminate form, just like 0 over 0 was, and we talked about 0 over 0. So to get rid of that indeterminate form, what we try to do is take everything that's here and end up with something divided by infinity instead, because if we have a number divided by infinity, we're good. All right. So what we're going to do is we're going to divide by the highest power of x or n or whatever it happens to be. These questions all have n's in them. So the highest power here is 2. The highest degree is 2. So I'm going to divide everything. I'm going to take the limit as n approaches infinity, but I'm going to divide everything by n squared. So I'm going to write it out so you can see what I'm doing. And then I'm going to simplify it. So n squared divided by n squared, that gives me 1. N divided by n squared is 1 over n. And 1 over n squared just stays as 1 over n squared. Okay? And then I go, okay, now I'm going to let n go to infinity. So if I do that, then I don't have to write the limit anymore. And I'm going to have 1 divided by 1 over infinity minus 1 over infinity squared. Okay, we know that a number divided by infinity is 0. So we get this, we get 1 over 0. And we go, wait a second, what's 1 over 0? Then we have to use a table of values. So we have to say, okay, well, what's happening as n gets really big? Well, you can't go from both sides of infinity. You can only go from 1, but if you put infinity in here, infinity minus 1 is positive, and infinity squared is positive. So that result is infinite. The answer is infinity. And if you just want to see it graphically, you can kind of get some concept of this if you look at the picture. We're looking at the algebraic expression, but we can always go and graph it. So if you look at just putting in the function x squared divided by x minus 1, it looks like this. Okay, and you can see that as I zoom out here, as I go out to infinity, even as I'm out to 22, it's 22 out there, you can kind of see that eventually, it's as x gets really big, y is going to get really big. So it makes sense that the answer is infinity. If I was approaching negative infinity, then what would happen, if we go back here, is I would have to go, okay, at 1 over 0, if this was negative infinity, and I'll just write it in here in a different pen so you can kind of see what I'm doing. If this was negative infinity, then when I put in negative infinity, this would be negative, but this would still be positive. So if it was negative infinity, all of this would be exactly the same, except at the end, the answer would be negative infinity. And it would be negative because this would be negative, but that would be positive. Okay? So we divide by the highest power of x if we have to, or n, or whatever the variable is. So here's another example. I have the limit as n approaches infinity of 4 plus 1 over n. So I start by direct substitution. I start by plugging it in. I get 4 plus 1 over infinity. That gives me 4 because that's 0. And it worked. And I got an answer. So no problem. The answer is 4. Okay, here, again, I just plug in infinity. I get 1/3 to the infinity. Okay. Now, what is that? So if you think about just 1/3 squared, what that gives me is 1/9, right? If I take 1/3 cubed, that's 1/27. 1/3 to the 4th is 1/81. What's happening is the denominator is getting bigger, the numerator is staying as 1. So we're essentially going to get 1 divided by 3 to the infinity, which is 1 divided by infinity, okay, which is 0. Right? And again, if you draw this, you can kind of see this, okay? So it's helpful sometimes just to draw them so you can kind of see what's going on, or you can get a concept in your mind of what 1/3 of the x. All right, you can see that as x gets big, it doesn't take very long before you get really close to 0. Okay, so it just conceptually it makes sense, but graphically you can see it, and it makes sense that way too. So that's that one. Okay, what about this guy? So when I look at this guy, I plug in infinity, and I'm going to get 1 minus 2 times infinity plus infinity squared divided by 3 times infinity minus 4 times infinity squared, okay? And a lot of mathematical operations sort of fall apart with infinity, but essentially that's infinite and so is that, because infinity squared is dictating what's going on, and so is this. All right, so if you take 3 times infinity and you subtract 4 times infinity squared, that number is going to be bigger. It might be negative, but it's going to be bigger. So what we're going to do is we're going to divide by the highest power of x, or in this case, n. So I'm going to take the limit as n approaches infinity, and instead of writing it all out, I'm just going to go, this is going to be 1 over n squared, this is going to be 2 over n, and this is going to be 1. On the bottom, this is going to be 3 over n and 4. So what happens is then when I let n go to infinity, I get 1 over infinity squared minus 2 over infinity plus 1. And on the bottom, I get 3 over infinity minus 4. So all of these, that goes to 0, that goes to 0, and that goes to 0. And what I'm left with is 1 over minus 4. So my answer is negative 1/4. Okay, because essentially what we can do is we can look at just the highest power, if they're the same on the top and bottom, and just take the coefficients in front of them. You don't have to do a lot of writing out, but that's how you deal with infinite limits. Okay, is just divide by the highest power. So if we look at this one's more interesting because of this minus sign. So this one actually we can say does not exist, and the reason it doesn't exist is because what's happening with minus 1 to the n is every time n is even, that answer is 1, and every time it's odd, it's minus 1. So the function's actually jumping back and forth. Okay, it's jumping from positive to negative to positive to negative, and so we can't determine what's happening out at infinity. So that one does not exist. But that's the concept of infinite limits. You just divide by the highest power of x if you need to, if you get infinity over infinity. Otherwise, you will get an answer generally, or something like this, and you can say it doesn't exist. And it doesn't exist because of this minus. If this is 1 to the n over n, it would be 1 over infinity, and it would be 0. So that's the concept. We're going to practice that. You want to practice just by getting some questions out, and we're going to do that in class. But that's the concept of an infinite limit, or what to do with infinite limits.